Hello everyone, my name is Martha Garcia, and my presentation for today is about centrifugal and centripetal forces with real-life examples. So let's get into it. Before starting with the video and showing the examples and the experiments that we're going to do today, we have to start by defining what a centrifugal force and a centripetal force is. A centrifugal force is a fictitious force that acts outward on a body moving around a center arising from the body's inertia. A centripetal force is a force that acts on a body moving in a circular path and it's directed towards the center around which the body is moving. The moon and the planets experience a centrifugal force which makes them want to fly off their revolutionary orbits, but the gravitational pull between the sun, the planets, the earth, and the moon act as the invisible string exerting centripetal force to keep them in place. For the first experiment, we're going to need a white balloon or a transparent balloon and either a quarter or a dime. It doesn't matter as long as it's a coin. Now we're going to grab the balloon and put the coin inside of the balloon. Then we proceed to blow up the balloon with the coin inside. Once we have the balloon all ready to go, we're going to spin the balloon and then we're going to observe that the coin is going around and around. This is like the planets going around the sun and the moon going around the earth. The moon being a satellite going in a geosynchronous orbit. Now, the difference between seeing this on space and seeing it here with the balloon is that in space it would just keep going and going. And here on Earth, the effects of gravity take place and it pulls down on the coin to eventually come to a full stop. Now, for the next experiment, we're going to need a tray with 4 strings attached to each corner, as shown on the video. We're also going to need a transparent cup and some water with food coloring. The food coloring is for us to see what happens to the water during the experiment. In this case, we're going to be using green and blue. Now, I'm going to place the cup of water in the middle of the tray and we're going to start swinging the tray back and forth until we can swing it in a circular motion. With the help of my friend, we can see on the video that the water is not moving as you swing the tray back and forth. Now, as you can see, the water stays inside the cup as the tray swings back and forth. There are 2 forces acting on the object. Gravity is always pulling the object straight down, and the centripetal force is applied by the string on the tray and objects, and is always going toward my hand. Since the combination of these forces act on the object the same way, their positions relative to each other stays the same. Final part of the video, I will talk about some examples of what we can see on our everyday life. One of the most common examples for this topic is a washing machine. Centrifugal force has the tendency to push the object following a curved path away from the center of the curvature. This characteristic of centrifugal force is used in washing machines. The force acts along the radius in an outward direction and hence can be used to throw the water molecules on the clothes radially outwards during the spinning of the washing machine. Another common example of this topic is a carousel. The platform upon which the horses and people are riding is the centripetal force that keeps them traveling in a circular motion. As long as the ride is moving slowly enough, the centripetal force of the platform can keep everyone and everything on board. In theory, if the carousel starts moving really fast, the centrifugal force takes over and breaks the hold that the platform had on the riders and the riders would fly off. Another common example associated with these forces, but less likely to be part of your everyday life, is a roller coaster. The centripetal and centrifugal forces are mostly found on loops in roller coaster. As the cart goes through the loop, there are 2 forces acting up on it to keep it on the track. Centripetal force keeps the cart from running off the track towards the outside, as it pushes towards the center of rotation. The centrifugal force is the force that keeps the cart from falling towards the ground in the loop, by pushing to the outside of the loop. On a roller coaster, you get at the very top, and what's happening is the track is pushing down, but you're being pressed into your seat even though you're upside down. We can relate this to the cup in the tray experiment that we did early in the video. Since the cup never left the board, The centripetal force was acting on the string to keep the cup turning as it moves along its curved path. The same thing happens when you're in the roller coaster at the very top. We've come to the end of the video. Thank you for watching.